values that you have in your data set. So the advantage of a stem and leaf plot is that it can give you a visual as to where if you turn it sideways, it ends up looking kind of like an histogram. So it's a good way to visually display data, but also still have your numbers right in front of you. So the first thing you're going to do is make a list of all possible stems. Then you're going to list the leaf of each data value to the right of the stem. You want to make sure that you list the leaves in numerical order, which your data set may not be in numerical order. So when you're making your stem and leaf plot, just make sure that you're putting your leaves on in order.
I've never seen a leaf and stem or stem and leaf plot.
Oh, you have. You just don't remember. I promise you have. And the next thing you're going to need to do is make a key if it's necessary. Sometimes they're not necessary. Sometimes it's pretty straightforward, but sometimes you need a key. So we'll use the same data that we were using for our frequency distribution. I had it sitting right here.
Oh, yeah, yeah.
What did I do with it? Our 21 pieces of data.
Now that I flip the page, I know what you're talking about.
See? So I have those test scores. I'm going to write them down, and as I'm writing them down, I'm going to try to kind of group them so that I can keep my stems and leaves together. So 75,
So are the stems kind of like the classes?
kind of. And they would be really close if we did our classes just by like 10, 20, 30. All right, so my stem and leaf plot. It doesn't, on your stem and leaf plot, it doesn't matter if you want to go from smallest to largest or largest to smallest. It doesn't matter how you write down your stems, as long as when you write your leaves in order. So I'll just go from, I'm gonna put my 2s up here, and I need to put them in order. So my stem is a 2, my leaf is a 1, that's the 21. Then I have a 3 for 23 and another 3. So this is what step 3 meant. Even though 23 is a repeated data value, it represents 2 separate test scores. 2 separate people made a 23, so you have to put the 3 twice. And then a 5. So it's a 21, a 23, another 23, and a 25. I don't have a 3 or a 4, so my next stem is a 5. 2 50s and a 51. And my next stem is a 6, and I got a 60 and a 66. And see, if you turn it sideways, it's a histogram.
Oh, wait, there was a none?
There was one in 98. Unless I made that up, which is possible. Oh no, there it is. Somehow I missed 88. Because there's an 88. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Oh! I got 2 of something. Terrible at this. You should have 21. I don't know. What did I have extra of? Anybody? I don't know.
There are 289s,
There are 2 89s,
250s,
2 50s.
223s.
Yeah, right next to
2
each other.
80s?
No, there's not 2 80s. So, not 2 80s. Okay. Okay, that's perfect. Okay. All right, on the next page, we're going to do a split stem and leaf plot. And actually on this one, you really, because we don't have a whole lot of data, you really don't need to split your stem and leaf plot, but we'll do it anyway, just so you know what it is. When you split a stem and leaf plot, you do that if one of your stems has like a ton of leaves. And in this particular example, the only stem of ours that has a lot of leaves is our 80. When you split it, you usually split it like at 5. So you would go 0 through 5, and then 6, 7, 8, 9. So we'll split it. So the rest, everything else is going to stay the same because there's nothing else really worth splitting, but just that one stem.
So fast.
So there's a stem and leaf plot. Next is a dot plot.
That was the square foot.
No, not yet. We'll get to that one in a minute. When you make a dot plot, you want to label the x-axis. Each data values can be represented by a dot or an X. And it's always above the value on the horizontal axis. Well, you'll see what I mean in just a minute. And I punched a hole where it was a 3, but step 3. Would be to look for and describe any trends and patterns that you see. So, if we're going to create a dot plot,
What was point B?
describe any trends or patterns. All right, so we want to put these scores, and our scores go from 21 to 100. So let's see. Maybe I can count by 2s. Yeah, I think that's what we're going to have to do. Is just count by 5s. Which means you won't use the whole line, but that's okay. So, I'll call this 20, 30, 40. All right, so we're using our same data, and you're just going to put a dot or an X above that data value, and they go up. So my first data value is 75, so you can put a dot right at 75. My next data value is 73, so literally a dot right there next to it. And there's one at 100.
Are those 2 points above the 90?
They're above 89.
Oh.
I had 2 89s. Now, a lot like a scatter plot that Julie mentioned, a scatter plot, when you do a scatter plot, you have to have paired data because you have to have an x and a y-axis. For a dot plot, all we have is just an x-axis because we just have one data set. All we have are test scores. But a dot plot will show us spread. It's real easy to look at spread when you see a dot plot. I can see that my data is very spread out. I can see that I don't have a lot of repeat scores. As a matter of fact, I only see 3 places where I have repeat scores. It looks like 23, 50, and 89 are the only scores that actually repeated themselves. So that's what dot plots are good for. If we had data that wasn't so spread, like if I hadn't given grades below a 50, which a lot of times I don't, like if they score below 50, I usually end up giving them a 50. If I'd have done that, then my 50 would have been real tall because all those 4 that are down here below 50 would have all just been stacked up at 50. which actually that's what I put in a grade book, but those, I pulled the real scores over from Edgenuity, whatever. I don't remember where I took those from, but I think it was Edgenuity. Is everybody good on a dot plot? A lot of times you'll see them, people do just X's instead, like just X. And the TI-84 calculator will do a dot plot, and you can choose whether you do dots or X's. A lot of times I'll do X's just because it's easier to see. Okay, now we're going to do a pie chart. We're all familiar with pie charts. So before we can make our pie chart, I need to collect some data. So I have a